Okay, in this lesson, what we're going to be doing is looking at factoring only the greatest common factor because nothing can be done beyond that. Again, just to remind you of what factoring is the opposite of simplifying. If we go from the factors to the simplified form, that's called simplifying, and to go from the simplified form back to the factored form is called factoring. In the previous lessons, what we did in the last example of 4.2, Part 1, Lessons 2 through 4, we always had an issue with factoring out the greatest common factor and then factoring beyond that. So the last one of the lessons was this first guy here, where the greatest common factor was 3. And then we were left with a trinomial of x squared plus 4x minus 5. In this particular case, that remaining trinomial, so leaving the 3 out of it, could be factored to be x plus 5 and x minus 1. Okay, and that was the final factored form. That took 2 steps. In this next one, what we did is factored out the greatest common factor of negative 5. We factored out a negative just in order to make the x squared term positive. So we're left with 3x squared minus 2x minus 8. And we noticed in that particular lesson that this trinomial remaining could still be factored to being, and you could look at those lessons again if you need to review what those were, could factor to being 3x plus 4 and x minus 2. And that would be the final factor completed form. In this last example, what we did is we factored the greatest common factor 3 out, leaving us with x squared minus 9, and that difference of squares, x squared minus 9, could still be factored to x plus 3 and x minus 3. So in many cases, it takes multiple steps to factor completely with the greatest common factor. In today's particular lesson, that's not going to be the case. You'll see that we can only factor the greatest common factor, and that is all. With algebra tiles, factor 6x squared plus 9x. You can see here I have 6x squared and plus 9x. So in this particular case, what we're going to be doing is trying to create an area. And there's nothing else needed to create that area. All I'm going to do is create that area by bringing all of these 9x terms and put them into 3 rows and 3 columns to create the area. And our area here, you can see, will be 3x along the top row and x plus 3, sorry, 2x plus 3 along the bottom row. This here is 3x, and this here is 2x plus 3. And we could even check that if we wanted to. So our factors are 3x, which we don't need to put brackets around because it's a monomial, and 2x plus 3. In that particular case, it would be done. We could check this, which would be 6x squared plus 9x, which does match the simplified form. A big hint to let us know that we cannot factor any further is that the term left inside the brackets, or the binomial, will just be linear. There will be no x squared term there. In that case, you can't factor that term any further. If you're to factor this without area, you do it the same way. You'd recognize that there is a greatest common factor, and that greatest common factor was 3x. You can divide these both by 3x, and by taking out the greatest common factor of 3x, you would be left with 2x plus 3, and that's the factored form. So you don't need to use algebra tiles. In the next particular example, what we're going to be doing is factoring 8x squared minus 2x. We can all see that there's a greatest common factor of 2x in this case. So we'll be left with 2x, and in the other factor we'll be left with 4x minus 1. And as we notice, there's no squared term here, so this linear term is already a simplified factor. So our factored form is 2x times 4x minus 1. You could check it if you wanted to, and you'd see here that we get 8x squared minus 2x, which is the simplified form. If you really wanted to see this with algebra tiles, you can see it right here. I already have the area there for you, but what you can see is this side here is 2x, and this side here is 4x minus 1. So the factors are, again, 2x, which we don't need brackets around, and 4x minus 1. Okay, So regardless of that method. Finally, the key ideas for factoring only a greatest common factor is factoring again can be done by creating an area with algebra tiles. You should always, regardless of the method, factor the greatest common factor first if possible. And if the remaining factors are both linear, or like I mentioned, there is absolutely no x squared term, there is no more factoring that can be done.